to start talking about ions. Ions are atoms that have a charge, and they get a charge by either losing or gaining electrons. So atoms that have either lost or gained electrons are called ions. They can have either a positive charge or a negative charge. Now, electrons are negative. So in order to have a positive charge, they actually have to lose an electron. To have a negative charge, they actually have to gain an electron. Stop me there. Okay, so ions are when atoms have either lost or gained electrons. And if it loses an electron, it now has one more proton than it does electrons, so it's going to have a positive charge. And if it has a negative charge, it forms a negative ion. That means it has one more electron than it does protons, so it's got a negative charge. And remember, up until now, we've talked about atoms that are neutral. They have the same amount of protons as they do electrons. But ions form when that atom is not happy and it either wants to lose the electron or it wants to gain electrons. Now, in order to lose and gain electrons, there's a trend. On the periodic table, you've got metals and you've got nonmetals. Those are the two main groups. Your metals tend to lose electrons, okay? So we'll say metals lose electrons. And when they lose electrons, they now have more protons, which makes them positive. Okay, they're going to have positive charges, and those are actually called cations. Cations are positive. So your metals tend to lose electrons because they're not happy, and when they lose their electrons, they now have more protons. So here's an example of sodium. So we're going to do sodium as an example to show you. So sodium, and I'll just go ahead and draw the element square. Sodium is Na. It's atomic number 11, I believe, and its mass is 23. So for a neutral atom of sodium, it has 11 protons, it's got 11 electrons, and it's got 12 neutrons. Now, sodium is in group 1. It's called an alkali metal. And once again, I had told you before, your metals are very reactive, especially in group 1, and your metals like to lose their electrons, which means they have now more protons than they have electrons. So drawing the Bohr model of the sodium atom, you've got 11 protons in your nucleus, and you've got 12 neutrons. Now, in the outer part, you've got your electrons orbiting around. I'm running out of room here. The first shell holds 2. 1, 2. The second one holds 8. 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to add one more. And that makes a total of 11. Now, this little electron out here is called a valence electron. This little valence electron is not happy. In fact, your sodium atom, because it has one valence electron out here, is extremely reactive. And what it wants to do is, it wants to bond with something where it can take that electron. So this little electron really wants to go away. So when this electron goes away, okay, in a chemical reaction, then this is no longer an atom, okay? It has 11 protons, 10 electrons and 12 neutrons. So you can see here that because it lost that one out there in the outer ring during a chemical reaction, it now has 10 electrons, 11 protons. Protons are positive, electrons are negative. There's one more proton than there is an electron, which means now it's going to have a charge. And it's no longer an atom, and it's called an ion. So that's your sodium ion. And the positive charge there just lets you know that there is just one proton more than it has electrons. Okay, so we just talked about your metal atoms that like to lose electrons. Now, your non-metals, everything to the right of the periodic table, like to gain electrons. These are called anions. And we'll say negatively charged ions. Okay? So chlorine, for an example. We'll look at chlorine. Chlorine is a nonmetal. Chlorine has the element square. You've got 17, you've got Cl, CHLORINE, chlorine. And then you've got atomic mass 35.5. Now, this number right here tells me your number of protons. It also tells me number of electrons. And you've got number of neutrons, which is 18. Okay? Now, your protons, your electrons, and your neutrons. Now, drawing the Lewis dot structure for chlorine. Okay, so we're going to look at chlorine, the Lewis dot structure. Okay, and this one's going to have several. Okay, so your protons and your neutrons are in here. And it's got 17 electrons. So we're going to say 1, 2. This one's got 8. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And this one's going to have 7. 2, 3, 4, 5, 6, 7. To make a total of 17. Now, this outer valence shell here can only have max of 8. And because it's got 7, okay, it's one more away from having 8, a full outer valence shell. And because it wants one more, it's going to receive. So sodium, that I had showed you before, sodium has 1 in its outer shell. Chlorine has 7 in its outer shell. So they form a bond because sodium likes to give up its electron. Chlorine likes to take it in. So what happens is, during the reaction, okay, you've got sodium that has given an electron here, and it falls right here. And everybody's happy. But now it's gained an electron, so now it has 18 electrons. So remember, it still has 17 protons, okay? It's got one more electron than it does protons. So it's going to have, now, a negative charge, and this is called an anion. Your nonmetals gain electrons, your metals lose electrons. And this attraction between your positive and your negative ions forms an ionic bond.